series of videos here where I'm going to do like an example of all the coding for doing one of these paper projects. So hopefully seeing me do it will help give you some ideas on how you're supposed to be doing your own project. So I've created a new file here in the paper folder with a couple of paper examples, so you'll be able to see what I do, use bits of my code to help with your paper by using that paper example. If we go down here and run this block that I already have in here to bring up the data sets, we can choose. I'm going to use the fatalities data set, US traffic fatalities. So I'm just going to go ahead and copy that to now create data fatalities. So now we have that done. I'm going to delete this so that it doesn't keep popping that up. And I'm going to move my library line up here. I'm going to keep all of my libraries up in this section. So just one for once. Okay. So we got the data set up. We can look at the data set here, kind of get an idea of what it looks like here. It's also helpful to put in help fatalities and run this whole thing, and then we get the information. So we have, it's a panel data set for the lower 48 states. It excludes Alaska and Hawaii from 1982 to 1988. And then the help file gives you information about all the variables that are included in the data set. Now, one of the most important things here in the help file, so we come down here and it has the references. It has a reference to a specific paper. So this reference, obviously the first place to start for getting references, that's a paper that uses more or less this exact data set. So I'm going to search for that, see if we can find that paper. If I go back here, if I click on the Science Direct, that would take me to a place where it's behind a paywall. You can probably still get it through using St. Martin's libraries. But if we just use Google Scholar Search, that's going to take me to a link that has a link to a PDF on NBER. So often going to Google Scholar will find you a free version of the paper. It's good too. This is technically the working paper version. It'd be good to find the published version to make sure there wasn't any change in, but I'm going to take the shortcut here and just use this. So if we go through this, their conclusion here is that higher beer taxes are associated with reduction in crash death, and this result is relatively robust across specifications. What I'm going to be doing across these things is, for the large part, recreating their results and then see if we can find any problems with it. So yeah, it's mostly a replication exercise that we're replicating what they did, but then we're going to see if they have any issues with how they did it. You'd want to read through this. Key things that we're going to look for here, though, is the descriptions of what variables that they use. Right? When you're writing your lit review, you want to make sure that you say exactly how do they do their study. So if we find, let me go to the method section here. You'll notice that the breakdown of this paper is about exactly how I've told you how to do it in your paper. So they're going to have their fixed effects model here. So we have here VIT, the dependent variable, is a transformation of the vehicle fatality rate for state I at time t. X is a vector of alcohol policy variables. Z includes other time-varying covariates. The alpha is a time-specific intercept, so this is your time fixed effects. And then you have this SI here. Those are the state fixed effects. So you have that two-way fixed effects. You have some controls here, and then here you have your policies. And this is a transformation of the variable that they're doing. Specifically, what the variable that they're doing, dependent variable, is the natural logarithm of the odds ratio. This is the natural logarithm of the odds ratio when you're doing that type of, when you use that as your dependent variable. That's called a logit model. They use this because the value is restricted to being between the range of 0 and 1, right? Because it's fatality rate, so it's always going to be between 0 and 1. So the odds ratio is if you take the fatality rate divided by, right? So this -1 means it's dividing by this. So it's the fatality rate divided by 1 minus the fatality rate. So that's the odds ratio, and then they're taking the log of it. Again, this is a fairly common specification. It's common enough that it has its own name, logit model. You can read more specifically about the logit model. I believe chapter 12, of the textbook, which I don't really intend to get to in the semester. It also says that it has the control variables, the amount of young drivers the percentage of the population that is in dry counties in the average miles per a person driving. These first off, note that if I go back to our fatalities, if we look at, say, they named their variable for young drivers, which is called young. If you look at it on ours, it's young drivers, right? The name is not the exact same. And then we have the amount of miles driven, whereas that's slightly different than the average miles per person. So the data set that you have here might have different names, it might have different things. Oh, let me go back to the policies. They have 5 different policies that they study. Whether or not they have breathalyzers, let me go back, see if I can find where they talk about this in the paper. So dram shop registration allows those injured to sue, administrative per se regulations, implied consent regulations, and then they have jail for legislation mandating jail or community service for the first DUI conviction. If we go back to our data set, you're going to find a variable for the breathalyzer test. Jail and service is broken up into 2 different variables, and the other 3 policies that they look at just simply isn't in our data set. So we can't do exactly what they do in the paper, but we can do very close to what they do in the paper. They're doing the same years, the same states as we have in our data set, but there are some differences in the data set. So it's important for you to notice how what they do is different than what we are doing. Okay, so let's create some of those variables that we talked about there. Okay, so I'm gonna start with modifying our fatalities data set. We're gonna use our fatalities data set and then modify it. So we're gonna do, mutate our data set, and we need to create first the rate, right? They start with the fatality rate. Well, what we have in our data set is the amount of fatal car accidents, and we can divide that by the population. So that gets us the fatality rate. And then we need to create from that fatality rate, they use the variable V for the dependent variable, right? And that V is the log of the odds ratio. And again, that odds ratio is the rate divided by 1 minus the rate. And make sure that we got the, okay, so we got the right number of parentheses there. So that is our dependent variable. That's a log ratio that there. We need the average miles driven per person. So we have the miles total, and we need to divide that by the population to get the average miles as they use. They used jail and service as a single variable where we have it as 2 different variables. So here we're going to create jail service equals jail equals yes, or you can, for the or, you can use a straight vertical line. Service equals yes. So we can, with this, let's check that that runs just fine. Nope, I did something wrong. Oh, you know what I did wrong? I forgot to load the tidyverse. So let's go back up here. So library. Hopefully that loads just fine. Wait for that to finish. And now it goes fine. Okay, so now if we open our data set, let's go to the end here. We see we have our V, our average miles, and then the jail service, so on. So we have the variables that we've created. So I think I'm going to pause the first video there.